Today our lesson is on polynomial functions, and our objectives are to classify polynomials and describe end behavior of a polynomial. So let's go over a few definitions first. A monomial is an algebraic expression consisting of one term. So 5 is a monomial, 3x cubed is another monomial, negative 15, and so on. So each monomial is separated by commas there. A polynomial is a monomial or an expression of a sum or difference of monomials. So remember, a monomial is one, right? One term. And a polynomial could be one or more monomial. So like if you look at this right here, 4 minus 3x, that's 4 is one monomial and negative 3x is another, and you put it together and all that sudden that becomes a polynomial. Okay, so it's pretty much one or more monomials. Here, 7x squared, that's a monomial, and that's a monomial, right? So together, it's a polynomial. Same thing here, right? And then here's a monomial, right? Because a polynomial could be just a monomial or an expression of a sum or difference. Okay, so those are just definitions. Both a monomial and a polynomial have what's known as a degree. So do you see the little numbers above, like the exponents right here? That's called a degree. So, for example, 3x to the 5th. This number, that 5, is a degree of that monomial. So the degree is 5. If we look at negative 3x, what exponent is after the x? So like, see this x right here? The exponent, if there's no exponent, is 1, remember? So the degree here is 1. So the degree is just whatever the exponent is. If we have a 5, okay, what's the exponent of this? Is there any variable? There's no variable, so here our degree is 0 because there's no variable. Okay? So take a look at all three of those examples. Those are monomials, right? All three of those are monomials. And take a look and see how we look at a degree. For a polynomial, the greatest exponent is the degree. So if we have an example of 4x to the 5th plus 3x squared plus 7, what's the greatest exponent? Well, the three exponents we have, or the two exponents, are 5 and 2, right? So out of those two, 5 is the greatest. So the degree is 5. Okay, x cubed minus 9x plus x to the 10th. The greatest degree here is 10, so our degree is 10. Now, if we have something that looks like this, this is 2x to the 5th y squared. Notice how see how this is one monomial? It's separated by that plus sign, right? So I'm going to actually box the different monomials here because this one's they look pretty different. They're a lot longer. So see how this whole thing, that's a monomial. And then here's a separate monomial, and here's another monomial, because remember with the definition of a polynomial up here, so up here, a polynomial is, it's separated by a sum or a difference, right? So this polynomial, see how every single monomial is separated by a plus sign in this case? That means there's 3 different monomials. So in this case, to figure out what our degree is, we have to actually add 5 plus 2, that's 7. So we're going to add our degrees for each monomial. So this whole polynomial right here, or monomial, this has a degree of 7. Okay, this one has a degree of 6. What about this one over here? This has a degree of 4. Okay, so our degree here, our highest degree is 7, right? Just like I said, we're going to add 5 and 2, that's 7. Then we have a degree here alone of 6, and then we have a degree here of 4. Okay, so we're going to be able to practice with these. Okay, so classifying polynomials. So there are 2 ways to classify polynomials: degree and number of terms. So the first way is degree, and the second way is number of terms. So these are 2 tables, obviously. So the degree in the first table, 0 through 5. I'm not going to have you guys go higher than 5. So these are, this is how you name by degree over here, this box, okay? And by number of terms is over here. So let's look at a couple examples to kind of figure out what this means. Oh, and also, notice how for classifying polynomials, when the number of terms is 4 or more, notice how 4, we call it a polynomial. For 5, we call it a polynomial. For 6, we'd call it a polynomial. For 7, okay, and you get it, right? So it doesn't matter how many number of terms are. Past 4, it's called a polynomial. So to classify, the first thing we need to make sure the polynomial is written in standard form. What is standard form? It's the greatest degree to the least degree. So remember, standard form is ax squared plus bx plus c. So that's the standard form of a quadratic equation. The standard form of any polynomial is the greatest to the least, okay? So that's the first thing we need to do. We need to put it in the greatest to the least for the exponents. We're going to look at the degree and put it from greatest to least. And then number 2, name by degree and then number of terms. So we're going to name by degree first and then number of terms. So for example, if we look at, if it says classify the polynomials, right? And you're looking at an example and it has this, 3x squared plus 5x cubed minus 9. Look at the steps here. We're going to follow these steps. To classify polynomials, we're going to make sure that the polynomial is written in standard form. Well, in this case, it's not written in standard form, so we need to do that. So remember, we write it from the greatest degree right here, the greatest degree to the least degree. So the greatest degree is 5x cubed. The 3 is greater, right? Up here, this 5x cubed, 3x squared, and then the 9 is last. That doesn't have a degree at all, right? It's just a negative 9. So the degree here, remember we look at the highest exponent, the degree here is 3. So this is the degree, that 3. Then we're going to look at the terms. How many terms are there? 1. Remember, the terms are separated by a plus or minus sign. 1, 2, 3. So there's 3 different terms. Okay. So let's look back up at our box. We have a degree of 3, so that's cubic, and we have the number of terms right here. The number of terms we said was 3, trinomial. So it's going to be called a cubic because of the degree of 3, cubic, and then trinomial because of this. Okay, cubic trinomial. That's what we'd call this. That's how we classify. So what if we have 7x minus 6x to the 4th? So let's look at our steps. Make sure the polynomial is written in standard form. Greatest to least degree. Our greatest degree is 4. Our least degree is 1, right? So we have to flip those around to write it in standard form. We have to write, and don't forget, the 6x to the 4th is a negative. You have to take the sign in front. So it's negative 6x to the 4th, and then the 7x is a positive 7x because there's no negative sign in front of it, so it's a positive 7x, so plus 7x. Okay, then we have to then number 2 says name by degree, then number of terms. So our degree is the highest exponent, which is 4. And how many terms do we have? We have 1, 2 terms, 2 terms. So we have 2 terms. So now let's look at so it says name by degree and then number of terms. So our degree is, nope, it's not 2, sorry. Our degree is 4. So we're going to call it a quartic, and we have 2 terms, so binomial. So if we wanted to classify that, we'd call it a quartic binomial. Okay? Okay, let's try this example. Last one, and then we're going to get on to the very last thing for this lesson. So we have negative 8x squared y cubed. Notice how there's no like plus 7x minus, there's nothing that's separating this, right? So if there's no plus or minus, this is called a monomial, isn't it? It's just 1. It's just 1. Okay? So there's only 1 term here. So we don't have to put it in standard form. So if we say standard form, it's already in standard form. Negative 8x squared y cubed. Why? Because there's nothing to move around. right? There's only one term. So now we're going to classify it by degree. Well, if you look back up at your notes, the degree here, okay, how do we figure this degree out? Remember when there's two different letters in the same, there's two different variables in the same term, like on the first page of this lesson? Okay, so I'll go back to that. Okay, so if we look here, let's look down here at this. Looks kind of like a mess over here now. But if you look down here, notice you see how in each term here, there was, like this is X and Y here. Let me use a different color. Okay, so there's X and Y in the same term. So we added those exponents together. And then this is just by itself, X to the 6. So that was just a degree of 6. And then here, we said, okay, well this degree here, the degree of that is 4. So we have 4, 6, and 7, our highest degree is 7, okay? So in the same way, we're going to look at this one and say our degree is 5 because 2 plus 3 is 5. So our degree for this is 5. Okay? If you have any questions on this, please raise your hand. I'll come around and explain it to you. Give you some more examples. Terms. How many terms do we have here? 1. So if we go back to classify it, a degree of 5 is a quintic, and a term of 1 is a monomial. So we'd call this a quintic monomial. Okay, so let's go on to end behavior, our last topic of today. So see, this is just kind of classifying this too. The end behavior is also just kind of classifying and describing different polynomials. So end behavior is what is happening to the graph of the polynomial as it goes to the right and left. So if we look at a graph, what's happening on the left and what's happening on the right in terms of end behavior? So that's what we're going to look at. So to determine this, first of all, the equation must be in standard form. All right, we kind of already figured that when classifying. And you need to look at the degree and the sign of the first term. Okay. So let's look at this. This is another table you need to write down. Don't write it down yet. Let me explain it. This is, and maybe you already wrote it down, but just take a look at what it looks like. So this is how we look at it. We're going to say, okay, if we have a positive first term, for example, if we have, I don't know, negative 8x squared, I'm going to put it in standard form already. That is not a positive first term. 8x squared minus 7x plus 1. Let's just say this is our polynomial. We're going to look at this first term only. We only care about the first term. What is the first term in this? Because it's already in standard form, so we're going to take this first term and we're going to say, okay, this number is a positive 8, isn't it? It's positive. So we're going to look for sure it's going to be somewhere here. Okay, because it's a positive first term. But we have to figure out if it's an even degree or an odd degree. Well, what's the degree of that? It's a 2. Is that even or odd? 2 is even, so we have a positive first term and it's even, so it's going to look like this. That's all that means. Okay, what if we had, I don't know, negative 3x to the 4th plus 5x minus 7x to the 6th. Let's do this to the 5th. Okay, so we have to, first of all, to determine this, remember the first step when we're doing end behavior is the equation must be in standard form. So we're going to put this in standard form. It's the greatest degree to the least degree. Take the sign in front. So we have a negative 7x to the 5th. That's the biggest one. Then we have a negative 3x to the 4th, so minus 3x to the 4th. And then we have a positive 5x plus 5x. So that's how you'd write it in standard form, right? Now we have to look at the degree and the sign of the first term. We only care about the first term. So we're going to look at this guy. And we're going to say, okay, it's a negative. So we're going to look here. It's a negative first term. And the degree this time is odd. So we're going to look here. So this is what our graph's going to look like. Okay. All right. So there's just a couple examples. So that's how you read the graph. I mean the table. Hopefully that makes sense. And then if not, raise your hand, I'll come around and help you. So if it's an even degree polynomial and it's a positive first term, it's going to go up on the left and up on the right. If it's an odd degree polynomial, down on the left, up on the right. So it's down and up. If it's negative first term and even degree polynomial, it's going to be pointing down, down, and negative first term and odd degree polynomial, up, down. And I'm going to show you some of these on Desmos. It's actually really awesome that every single polynomial fits into this table in terms of what it looks like. Isn't that cool? I mean, they all look the same. They all have the same shape. They're just going to be either wider or fatter or, you know, all that stuff's going to change. But in terms of what they look like, they're all going to be they all have the same shape. So just depending on the first term when it's in standard form. Okay, so notation in higher level math classes. So in higher level math classes, for example, after this class is pre-calculus. In pre-calculus, if you're given an example like this, first of all, is this in standard form? Yes. We have a degree of 2, which is even, right? Okay, so we're looking here on our table, and we have a first term that is positive or negative. Positive, because the first term is 1. So we have a positive first term and even degree polynomial, so the graph's going to be up and up. Okay, so this is what it would look like if you were in a higher level math class. This part isn't. This is just what we're going to do this in this class. That's going to be on your My Open Math homework. But if we were in a high level math class, this is what you guys are going to be seeing. So as x approaches, this arrow means approaches. As x approaches negative infinity, that means if you're looking at a graph, okay, if you're looking at a graph, as x approaches negative infinity, where does x approach negative infinity? This way. It keeps going on forever in this direction. This is the x, right? This is x. And if it keeps going in the to the left, that's approaching negative infinity. So as x approaches negative infinity, remember f of x is the same thing as y. So as x approaches negative infinity, y approaches infinity. Okay, so it looks like this. Y approaches infinity as x approaches negative infinity, right? And then, I shouldn't have drawn this right here because my next piece of this is going to be right underneath it, but let me show you. Then the next piece, then it says, so from left, as x goes to the left, y goes up. So as x goes to the left, just like I showed you in that picture, as x goes to the left, y goes up. And then as x goes to positive infinity, so this way, as x goes to positive infinity, y goes to infinity. So as x goes to the right, y goes up, right? And isn't this what we just classified this piece as, up and up? Which looks like this, right? So this notation is just a fancy way of saying this up here. And this is what the graph would look like either way, right here. This is where we classified it as. So if you didn't understand that last couple minutes, that's okay. I just wanted to show you that this is what you're going to be learning in classes such as pre-calculus and even above that.